Hello, everyone. Welcome to our webinar. We'll get started in just a couple minutes. All right, let's go ahead and get started. Welcome to our webinar today, everyone. My name is Justin D'Souza. I'm a quantitative specialist here at SPSS Solutions. During today's webinar, we are going to cover SPSS data cleaning and management steps. I do have a sample spreadsheet that we are going to go through, and we'll kind of walk through the cleaning of the data, removing for non-responses, identifying outliers, creating composite scores. We're going to send everyone a copy of the webinar, as well as a copy of the PowerPoint. If you have any questions, you can type those into the chat box, and at the end of the webinar, I will be doing a question and answer session. My colleague Sierra is helping as well today, and she will be answering any questions pertaining to the services that we provide. She'll be providing hyperlinks in the chat box. So just let us know if you have any questions. So I'll start out by giving a brief overview of the services that our company provides. Then we'll dive into SPSS cleaning using a sample spreadsheet. And we'll conclude with a summary and a Q&A session. Our company assists with every part of the dissertation process, starting with topic development and going all the way to final PowerPoint defenses, as well as journal publications. The way our company works is we have quantitative and qualitative specialists who can help you with the methodology. And we also have literature review specialists who can help you with the theoretical framework, and primarily chapter 2 for most universities, that is the literature review. If you need help with framing research questions, determining your research design, identifying what instruments to use to collect your data, kind of formulating your instruments and data analysis plan, what analyses are best to address your research questions. We can host surveys for you on our own SurveyMonkey account. And then we can help actually crunch your numbers and develop a APA write-up for you, as well as the discussion chapter and PowerPoints for proposal and final defenses. And once you've concluded the dissertation, we can help you condense it into a journal publication. If you have any questions about the services we provide, you can give us a call at 727-442-4290. Here we have a couple hyperlinks in which you can view our past webinars. The second link here will give you the recordings for the past webinars we've done. And we've covered a variety of topics from the literature to quantitative and qualitative methodologies and results, as well as tips to get through the IRB process. And then the first link here has a list of future webinars we will be conducting. So assuming that you're doing a quantitative study, you're most likely going to use SPSS or SAS or maybe R. Stata is another option. I would say SPSS is the most intuitive software to use because it's point and click, and there are many tutorials online On YouTube, there's a lot of tutorials that will teach you how to use every function. So assuming you use SPSS, there are many ways you can collect your data. You can use SurveyMonkey and Qualtrics, and they will extract the data right into SPSS for you. So the first thing you want to do is add an ID variable so you can keep track of every participant. Throughout the data analysis process, you're going to be sorting your data in a different order. And this ID column that you use is going to be very useful to retain the original order of your spreadsheet. Then you want to name every variable of interest in your survey. Assuming you're using multiple surveys like job satisfaction or maybe leadership, you want a short phrase that summarizes what the variable is measuring. So if you're using the JSS, which measures job satisfaction, this contains 6 survey items. So you want to create 6 variables of interest ranging from job satisfaction 1 up to job satisfaction 6. And perhaps the most important advice I can give is saving often. You want to save after you make any adjustment to the spreadsheet, whether that's removing for outliers or removing for missing responses, creating composite scores. You want to save after every step so you can keep a running record of how you started and how you completed the data management. This would be good if you send the data to your committee or to another statistician. They can kind of follow the logical order that you followed. Okay, so I do have a sample spreadsheet here in SPSS, and this was extracted directly from Qualtrics. And the purpose of this survey was to look at the relationship between leadership effectiveness, job satisfaction, and organizational performance in the workplace. So we had, as you can see here in SPSS, there is data view, which you can see the actual survey responses, and there is variable view, where you can see details for what each question was asking. The first 7 items were measuring leadership effectiveness, then the next 6 were measuring job satisfaction, and then the last 5 here are measuring organizational performance. The first thing we need to do is add an ID column. So we're going to go into data view here, and we want to scroll all the way to the bottom and see how many participants we have. It looks like we have 91. And another good thing to do is just kind of eyeball and take a look at how the data look. Are there missing responses? In this case, yes. We have some cases where data is just missing throughout. Maybe somebody provided consent, or maybe they did not meet the inclusion criteria for your study. And then they weren't allowed to continue with the rest of the survey. Those are people we'll probably want to take out. And then you can also see some participants responded to the full survey with the exception of an item or 2. You know, there's just a couple missing items for these people. So we'll want to handle the missing data, but the first thing is add an ID column. So I'll go into Excel. Unfortunately, there's no quick way to do this in SPSS. I really should add a command, but what you'll do is you'll go into Excel and just start the list. And then once you start the list, you click this bottom right dot, and then you can drag down 93. Okay, so we have 93 participants, and we're going to add a variable right here for ID. Like that. Now everybody has a number. I added a couple too many, 91. We have 91 participants. And then the next step is naming all the variables of interest. In a very similar format, we'll go into Excel. And we first need to start the list. Leadership effectiveness. And this is going up to 7 items. Then the next part was job satisfaction. And this included 6 items. And finally, we have organizational performance. And this one had 5 items. So now I can take these labels, put them in SPSS under the variable view, copying and pasting. Okay, so I believe we have tackled the first slide here. Add an ID column, name every variable in the spreadsheet, and now save. And usually when I save, put it in a new folder here. Usually I put the sample size, which is 91 in this case, and I'll put today's date. So that's step 1. The next step is changing Likert scaled items or string format variables to numeric format. So if you ever see words for a Likert scale, strongly agree down to strongly disagree, usually you want to convert those to numbers. 1 to 5 or maybe 1 to 7 is a common procedure. In this case, they were all 1 to 5. As we look at the data in data view, we can see some of the survey was already collected in numeric format for leadership effectiveness and job satisfaction. However, for organizational performance, all of these items are written as words. We need to convert these to numbers. So you can quickly do that under transform. We'll go to transform and recode into same variables. And then I just need to move the last 5 items into this right box. And then we identify what the old value was, which is in here, and we need to change it to the update. Will be just a number. The quick way to do this is to find, you have to look at the scoring instructions for one thing, make sure that there was no reverse coding that was required. Meaning that you don't have any negatively phrased items. So we can take strongly disagree, copy that, and put it in this box. And the new value for strongly disagree is going to be a 1. Then you need to find a disagree, copy, old and new values. This becomes a 2. Neither, or the neutral response, a 3. Agree will be a 4. And strongly agree will be a 5. Like that. And whenever you do a command in SPSS, you'll see the option to click OK and the option to click paste. If you run OK, it's going to run this command and change everything to numbers, which is what we want. But you also want to keep a running record of what you've done. And to do that, you can click paste. Paste is going to give you the code or the syntax for running that analysis. And this is what, once I clicked paste, this is what pops up. And this is the code for recoding from string to numeric. And you can put comments in here. This looks like maybe another language, but we can put a comment that summarizes what this command did. And to do that, you just put an asterisk at the beginning, and we can identify that this was changing format, words, numbers. Okay. And having these open side by side, I can show you how to run syntax. Okay, we have the data on the right, syntax on the left. If I highlight the syntax and click this green arrow, you'll see all the Likert scale change to numbers like that. Okay, so you just have to highlight what you want and click the green arrow. Now, SPSS still thinks that these are words. And how do I know that? It's because we have this little character A right here. So it still hasn't recognized that these are numbers. We have to change this manually. You go into variable view, and all of these are numeric. The last 5 are string. We need to change these to numeric. Once you've done one, you can just copy and paste down. Okay, the next step, that was the first step here, recoding from string to numeric. The next thing you want to do is closely look at the scoring instructions for your survey. Sometimes there are negatively phrased items, which is something I brought up just a few minutes ago. And if you have negatively phrased items, you may need to reverse score those items. If you don't have scoring instructions, you have to read the questions very carefully. So we can see here for job satisfaction, higher scores, here, eliminate this. Higher scores on these questions were indicative of higher job satisfaction. And we can see that we have a question like this: my job responsibilities are clear. If someone responded a 5 or strongly agree, that means they had higher job satisfaction. But for a question like this, I'm not satisfied with my job security, we would hope that participants disagree with that item if they have high job satisfaction. We need to reverse code anything that is negatively phrased here. So it's going to be these 2 items. I'm not provided with the tools and equipment I need to do my job, and I'm not satisfied with my job security. These 2 items are negatively phrased. But just like we did before, we need to go into recode, and you can use either same variables or different variables for this. I like to do recode into different variables because it allows you to keep the reverse coded items and the original items. We'll click recode into different variables. Then we need to move over job satisfaction 2 and job satisfaction 4, this box. Then we need to give the recoded variable a name. This will be job satisfaction 2 reverse. And the next one, very similar, will be job satisfaction 4. Now the Likert scale for job satisfaction range from 1 to 5. So when you reverse code things, you want to invert the Likert scale. You want a 1 to be a 5, a 2 to be a 4. 3 is right in the middle, so it doesn't really matter. It stays the same. A 4 becomes a 2 and a 5 becomes a 1. So that's what we do here in this box. Once we click old and new values, a 1 becomes a 5, 2 is a 4, 3 stays the same. You don't actually have to put that one in, but I like to do it just for the visual. So you can see it going up 1, 2, 3, 4, 5 and down 5, 4, 3, 2, 1. That is what we want. And again, I could click OK and it will run this command, but I'll click paste instead. You can keep a running record, and here's the code for reverse coding. Reverse coding negatively phrased items. Again, you highlight this code and you click the green arrow, and it's going to run. So you'll see 2 new variables have been added to the spreadsheet. And these are the negatively phrased and now reverse coded items. What we want to do is we need to put these in the correct spot in the same order as the survey. So I'm going to move job satisfaction 2 up here and job satisfaction 4 up here. And we want to move the original items to the bottom, kind of get them out of the way. And then you need to take over the value labels. You can see it's blank. We don't know what this question was asking, but we have it right here. So I'm just copying and pasting. Okay, and now we need to save. Okay, so we did quite a few adjustments, and it's good to be detailed. You know, you want to say what happened in between the last save. So here we have changed from string to numeric and reverse coded items. Very good. The next step is handling missing data. Okay, there are many ways to handle missing responses. So most likely when you do any inferential analysis, you need to run a power analysis to determine what's your minimum sample size requirement. We've done webinars on this. If you have questions about power analyses, the most common software used for this is gpower. gpower will tell you what's the minimum sample size for a specific analysis that I'm running. If you're far above your sample size requirement, then you can consider removing any missing responses. Even if people missed a few items, a complete data set is better than an incomplete data set. And so in many cases, if you're far above it, you can just remove missing responses. But if you're right on the threshold, or if you're below the sample size requirement, you might want to consider replacing missing data with an average or a median. I'll show you how to do that. There's also more complex techniques like imputation, in which you can predict what missing responses will be, and that is a function in SPSS. There are so many YouTube videos on how to handle missing responses. And depending on what reference you read, you might see a different approach. You just have to pick a method early on and justify it. Okay, so we can see here, we had 91 cases to start out with. First off, I'm going to remove people who didn't respond at all. Okay, and we can see those here. A quick way to find those is just pick any column in the middle and sort in ascending order. You right-click on the variable name, sort in ascending order. That will bring all the missing responses. Now you can quickly just delete these rows. Right-click, clear. All right, we made quite a big adjustment there where our sample size has dropped from 91 to 86. This is a step where I would save again. Our sample size is now 86. And we removed all missing responses. Okay. Now we need to handle the missing responses in the middle. You know, I can see one here and here. So we have to figure out what to do with those. And usually I would use mean imputation. So that's replacing the missing value with the average of the column. So essentially SPSS would take the average of this column right here, and whatever the average is, it'll replace the missing value with that average. Okay, so to do this, we'll go to transform and replace missing values. And I'm going to put in everything. So literally every single survey question, I'm going to put in this right box. Just because, say you could miss an item, that you missed in the middle that didn't have a value. So I just put everything in, just play it safe. And you can see the default procedure is a series mean. So what it's going to do once I can click paste again. So I'll click paste, and now we have syntax for replacing the missing values. Replacing missing values with the mean or average. If I highlight all this code and click the green arrow, that is going to create new variables that have replaced the missing responses. Okay, so let's click the green arrow. And if you see in data view now, we have a ton of additional variables now. And the replaced missing values ones have a _1 after them. And you'll see that the value labels are now different as well. Series mean is what it says. So I just need to copy the old labels over here and bring it down like so. So essentially, we just need these variables now. You don't need to use these. I like to keep them in just as a reference point, but whenever we're doing analyses, we're only going to use these variables. And just to illustrate, here was that missing response for job satisfaction 3. Let's scroll to the right and find job satisfaction 3. Here's that value. And now it's 2.15, which was the average for job satisfaction. Okay. So that's imputation, replacing missing responses. Let's save another spreadsheet here. Replace missing values with the average. Okay, one of the final steps is creating composite scores. So again, very much like when you're looking at reverse coding, that process I brought up earlier, usually in the scoring instructions, they will tell you, do you take a mean or sum of your survey items? When you look at surveys like this that are Likert scale, we don't usually want to examine leadership effectiveness 1, 2, 3 on their own. We want to create an overall score that encompasses leadership effectiveness, an overall score that measures job satisfaction, and one overall score that measures organizational performance. You don't usually look at each item on its own. That's a generalization, but in many cases, you need to create a composite score. To do this, we will go to transform and compute variable. And the first thing you have to do is give this variable a name. We'll do leadership effectiveness first. What you do is you type leadership effectiveness, and usually I'll put an underscore overall, or you can, depending on what procedure you use, you could put sum, or you could put mean. I'll just put overall. And then we need to take a mean. So I'll put mean of job satisfaction or leadership effectiveness first, leadership effectiveness 1. And there are 2 ways to do this. You can put a comma and then put the second item, a comma, the third item, comma, the fourth item. The quicker way to do it, if they're in perfect order, is to put the first item and then write the word 2 and put the last item. This will take an average of this first item up to the 7th items. All 7 items are being included. I'll click paste, and then I'll do the next 2. Clicking paste, put the code for this right here. Take an average of the 7 items for leadership effectiveness. Then we can do job satisfaction. This is why it was important to put the reverse coded items in order of the survey, because then you can just do job satisfaction 1 to job satisfaction 6, and it's going to include those reverse coded items. We don't want to include these two here. Okay. And finally, organizational performance. This item to item 5 and paste. All right, so now we have the syntax here for 3 composite scores. Creating composite scores. All right, so then we highlight this code and click the green arrow. Now we have 3 variables at the end of the spreadsheet that represent leadership effectiveness, job satisfaction, and organizational performance. That's pretty much it, for creating composite scores. Now you could essentially run statistics, but one of the last things you should do is look for outliers. Okay, outliers, there's many ways to do this. You can do it visually with box plots, but you can also do it numerically through standardizing the values. I'll show you both ways. So the box plot method is by going to analyze and then descriptive statistics and explore. Then if I put in these 3 variables of interest, and before I preface this, outliers, for anyone who's not familiar, outliers are any extreme cases in the spreadsheet, values that go beyond the norm, and many times you want to remove those cases. Okay, so I put the 3 variables in this right box. Then let's check the statistics box here. You actually don't need to check mark that there. There's another way to do it. We'll check mark normality plots and click OK. So here we can see the box plots. Okay, and if there is an outlier, it's going to be identified in this box plot. We don't see any for leadership effectiveness. We see one potential point here. So case number 78 had a high job satisfaction score. In SPSS, if it's just a circle like this, that means it's a high value, but not necessarily an outlier. An outlier will have a star or an asterisk. So this is just a point that you should probably look closer at, but not necessarily remove. And then we have organizational performance. We had no outliers there. So the numerical way to check for outliers, not visual way, is to go to Analyze, Descriptive Statistics, and Descriptives. And then put in your 3 variables of interest right here. And then check mark this box, Save Standardized Values as Variables. Once I click OK, this is going to create 3 new variables that are going to be standardized around the mean. Okay, like this. And according to the citation, standardized values that go beyond positive 3.29 or below negative 3.29 are outliers. So you can take these standardized values and sort them in ascending and descending order like this, or ascending. And we can see that the lowest value is negative 0.97. It's not even close to 3.29 or negative 3.29. Then you go in the opposite direction, sort descending. So the highest value we have that is standardized is 2.79. That's not at the 3.29 threshold. We don't have any outliers here. for leadership effectiveness, then we follow the same procedure. The other two variables, job satisfaction. This one is pretty close. We had 3.24. This is probably the case that in the box plot for job satisfaction, it's most likely this value right here. Someone scored quite high on job satisfaction, but it's not at the threshold, not at 3.29. It's just slightly below that, so I would not remove that case. And then organizational performance, sort in ascending, no extreme small values and no extreme high values. Altogether, we did not remove for any outliers. The final sample size will be 86. Okay, and that's really one of the last steps. So then you save, and then once you've created a final spreadsheet, I'll put final here. Okay, and once you've done that, the next steps are usually running descriptive statistics to look at your demographics, frequencies and percentages for things like gender, ethnicity, education level. For age, something like age, you can use means and standard deviations. Then you need to look at your research questions and determine what's the best analysis to address those questions. And most inferential analyses, like regressions and t-tests and correlations, there are specific assumptions to check for those analyses. Like you might want a normal distribution, homogeneity of variance, multicollinearity. There's many assumptions to check. And that's usually something you need to do before running the analysis. And then you can address your questions and hypotheses with those analyses. So we'll now do a Q&A session. If you have any questions, you can type those into the chat box. If you have any questions about the services we can provide, you can give us a call at 727-442-4290 for a free consultation, or you can email us at info@statisticsolutions.com. Okay, do we have any questions? I did see that some were coming in. Will we receive the SPSS or Excel data set used in today's webinar? Yeah, I'll talk to my manager and I'll see if we can have that sent over, as well as the webinar and the PowerPoint. Yep, Max, I'll look into that, okay, to see if we can send the first spreadsheet and the final. Grace, that's a good question about the series mean. That's one of the limitations of replacing missing values, is that it was a 2.15, but that is the actual summary value for the spreadsheet. So usually you just keep it as 2.15. The alternative is using a median as opposed to a mean. So most likely when you use a median, it will be a whole number. But that is a common procedure used, and decimals are okay. And then we have a follow-up. How do I manage I don't wish to answer responses? Usually you treat those as missing, or change their response to a blank, at which point you can then use mean or median imputation to replace those values. Do we have any other questions? So as a follow-up, how do I manage I don't wish to answer responses? Yeah, usually, I would personally take them out. You don't want it to follow the Likert scale. So maybe I don't wish to answer was a 6 or a 7. You don't want to keep that as a 6 or a 7, because when you create your overall score, you don't want those 6s and 7s to correspond to I don't wish to answer. It needs to fall on the Likert scale, strongly agree to strongly disagree. So usually I leave them blank. You'll take out the response for people who said I don't wish to answer, because that is essentially, statistically, it's the same as a missing response. It's not going to be beneficial. Keep the actual value in there. And then you can choose whether to exclude those people, or you can use missing value responses, or you can replace the missing value with the average or the median. How can I run, okay, this is a question from Navison. How can I run a general regression model using SPSS? We're not diving too deep into analyses in this one. This was more just data cleaning, but just to illustrate, if you mean like a linear regression or an ANOVA, regressions are under this box. Regression and linear. And then if you're looking for an ANOVA, I don't have a demographic variable to use here to run an ANOVA, but you go over here, and it depends how many dependent variables you have. Okay, so usually general linear models are running ANOVAs, and that means you're testing for differences in a variable between groups. Okay, so if you put in your dependent variable, whatever it is, one of these composite scores, and then your fixed factor will be what you're testing for groups between. Okay, so whether that's whatever your groups are, treatment, control groups, gender, ethnicity, any categorical factor would go in this box. And then there are many options to select. Usually you want descriptive statistics, you want a homogeneity test, lots of different options in here to check out. Usually you want to do post hoc tests for pairwise comparisons. I believe we've done webinars on ANOVAs in the past if you want to check those out. Yes, John, could that affect your standard deviation if you use 6 or 7? Absolutely. Yeah, that's why you want to take out the 6 and 7 and replace it with something else. Replace it with treat it as a missing response essentially, and replace it with the average or the median. Then it's not going to impact your standard deviation. Or just leave it blank. Just leave it blank and you can still compute a composite score for those people. Will you have any sessions for regressions in the future? I will be doing, I believe it's next month, early April, I'll be doing a webinar on regression models, and we'll be diving into SPSS a bit. I'll be defining when to use each regression. We have linear regressions, logistic, binary logistic, ordinal logistic. We will be doing a webinar like that in the future. Okay, Astawus, how can we input missing data during analysis? I think I'll need a little more information for that question. Do you mean impute or input? I think there's I'm not sure what word you meant to use there. Imputation is, yeah, I would watch some YouTube videos on imputation. It's quite an advanced procedure. But under analyze and missing value analysis, I believe. And that will give you, opening somewhere in my computer on one of my screens, I can't find it. Oh, multiple imputation, actually. This is what I was looking for, multiple imputation. And you can impute missing values. And this is going to predict what the missing values should be. More of a complex procedure, and there's a lot of literature that supports it. Okay, we have a question from Grace. I had I don't wish to answer questions or responses for demographics. And I keep those cases and have different sample sizes for each variable. Would that be an issue when running linear regression models? Many ways to handle that. Okay, so if for the demographics, it depends how you're using those demographics. If you're just using them for descriptives, then I would keep the I don't wish to answer as a response. So you can specifically see how many people indicated I don't wish to answer when you do frequencies. If you're including those demographics like age and education as predictors, then you'll want to transform or you'll want to manipulate that variable. You don't want to have I don't wish to answer as a response. It's not really beneficial for statistics when you run a regression. That's where you want to replace it, either leave them, most likely leave them blank, what I would say. And yes, that is going to impact the sample size. I completely understand you have to give participants the ability to say, I don't wish to answer. Many IRBs say that, but statistically it's not ideal. You don't want to have those as possibilities. You want to have forced responses that fall on the Likert scale. Sometimes the question just doesn't apply to the person, and that is truly a realistic depiction. I don't wish to answer. Statistically, it causes problems. So I would eliminate that as a possibility if you can. Check with your IRB. So which version of SPSS allows me to do linear multivariate regression in hierarchical regression models? I believe the basic one here does. Max, thanks for helping me out with these questions. But yes, I think you're right. Just the basic version should help here. If you go to, let's see, you mentioned hierarchical regression. So hierarchical regression, there's hierarchical linear modeling and there's hierarchical linear regression. Linear regression is done by putting in predictors in one step. Say I put, how does job satisfaction predict organizational performance? And a hierarchical linear regression would then be adding a predictor in another step. You click the next box here, and then we can put in another factor. And just to run this one to illustrate, it's actually not, I meant to do a different variable here. So job satisfaction, we'll put this. So this is a hierarchical linear regression where it's done in 2 steps. Many times this is used when you're controlling for demographics. So you would put in your demographics in step 1, and then your key predictors in step 2. So that's how you do a hierarchical linear regression. Linear multivariate regression, it's not the usual terminology I see for it. Do you mean just a multiple linear regression, a regression with multiple predictors? That can be done that's essentially what we ran here. But instead of doing multiple steps, reset this. A multiple linear regression would be just doing everything in one block as opposed to partitioning steps. Okay, so you can do both in just the standard version of SPSS. Okay, let's see, we have some questions in the Q&A box. Is there an important difference between using means and sums for composite scores? No, not really. It's actually going to give you the same exact results if you do inferential analyses like regressions and correlations and t-tests. It's going to give you the exact same results. It comes down to the interpretation. For means, you're going to have decimals as possibilities. So it's like you're bringing your scale down around the Likert scale. If you use a Likert scale ranging from 1 to 5, your composite score is going to range from 1 to 5 if you use means. Sums are going to give you larger values for interpretation. It really comes down to what the original authors used. So you'll want to look at some validation articles and determine what they followed. But essentially, it's not going to make a big difference. You're going to see the same results. It's going to alter the interpretation a little bit. If you do not meet certain assumptions for a statistical test, and you still run it and report results as long as you explain why you're still running it. Yeah, there's a lot to that question. Okay, so for assumption checking, it depends what analysis you've proposed, first of all, because many analyses have a non-parametric backup. So say you propose to do a Pearson correlation, and one of the assumptions of a Pearson correlation is that your data follows a normal distribution. Say normality is violated. There's a backup, the Pearson correlation. You can run a Spearman correlation as a backup in that case. But some tests don't necessarily have a backup, like a non-parametric backup. Another example is like a t-test, an independent t-test. If the assumptions are violated, you can run a Mann-Whitney test. For an ANOVA, you can run a Kruskal-Wallis test as a backup. Some analyses don't have a clear-cut backup. So you have to provide justifications for why you proceeded regardless. And many times a very strong justification for that is using your sample size. If you have a large sample size, you can proceed despite violations of normality. I'll type this in the chat box, but this is called the central limit theorem. If you want to Google that. Okay, so the central limit theorem basically says that the larger your sample size, the more it tends to approximate towards a normal distribution. So if you have a really large sample size and assumptions are being violated, then you can justify proceeding anyway with the central limit theorem. Okay, we had a question from Astawos. In this case, during analyzing job satisfaction, is there another method instead of using the mean score? Are you talking about replacing the missing values? I'm not exactly sure what you're pinpointing about job satisfaction. If it's replacing the missing values, then the most common procedures are replacing with the mean, replacing with the median, or imputation. And then the last step is just removing missing responses altogether. So just deleting the row. And obviously that's the last resort. You don't want to remove data if possible, but sometimes you have no other choice. And if you have a very large sample size, it's not going to affect the data set too much, taking out a few cases here and there. You're welcome, everyone. Thanks for joining. If you have any questions, I do one-on-one consulting as well. You can reach out to the number that I've provided over here. And Janine will give you a free consultation and kind of describe how it can best assist. Okay, so how do you run a non-parametric test for Friedman ANOVA? I don't have a good example here for the data. A Friedman ANOVA is most likely used to look at differences over time. So it's the non-parametric backup to a repeated measures ANOVA. But to do a Friedman ANOVA, you need to have matched data and most likely at least 3 time points, maybe a pre-test, post-test, or a follow-up, or you're comparing scores across a scale. You go to analyze and then non-parametric tests, and then legacy dialogues, quite a few menus for this one. And then K related samples right here. And you'll see right here, bottom left, Friedman is checkmarked. So that is going to run the Friedman ANOVA. And then you have to put in your pre, post, and follow-up. Whatever you're testing for differences between, you'll put that here. It looks like we're going to be sending a copy of the webinar 24 to 48 hours from now. And it'll be uploaded to YouTube as well. Awesome. Thanks for joining us, Candace. Appreciate it. Take care, Max. Thanks for joining us. Do we have any other questions? I don't think we have a WhatsApp number associated with our company, but you can email us. I provided the email right here, info@statisticsolutions.com. I just put it in the chat box. All right, do we have any final questions? Sounds good. Yep, email will be great for us as well. All right, thanks for joining, everyone. Just to give you a heads up on what's on the horizon for the webinars. Take a look. It looks like next week, or actually this week still, the 24th, on Thursday, we'll be doing a chapter 1 webinar. And if you happen to be doing a quant and qual, or maybe a mixed methods, you can join for our qualitative results chapter webinar. That will be this Friday. So let us know if you have any questions. Thank you so much for joining and have a great evening.